Good morning to all of you. So today I am going to show you the motor, Fleming's left hand rule. Motor means from electrical energy to mechanical energy. Electrical energy to mechanical energy. So I have a model of motor. Here a parts are here. This we are going to call it as armature. This is two-pole motor actually. This is the armature and we have here brushes and two external magnetic field, both the ends. And everything is fixed to the one base. And then we have here eliminator. Eliminator means it's going to convert AC to DC. How much volts we want, it's going to give, like a 2 volts, 4 volts, 6 volts, 8 volts, 10 volts, 12 volts, like that. Like a 8 volts, 2 volts, 4 volts, 6 volts, 8 volts, 10 volts, 12 volts. If I am going to pass a current through this, already in previous class we understood if you are going to pass a current through the insulated copper wire, it's going to become an electromagnet. That we already understood. But here is the concept is one end is going to become north, another end is going to become south. One end is going to become north, another end is going to become south. Here is also one end is north, external magnetic field is one end is north, another end is south. Here what will happen? The couple is going to create. What is a couple? In electromagnet, means in motor, the couple is very important. Two equal and opposite forces acting on the same plane and different directions. Different directions. Couple means two equal and opposite forces acting on the same plane in a different directions. Two equal. See here, this is electromagnet. This is also a magnet. Here, this side, this side. Two equal forces acting on the same plane. Plane means one layer, the same level. Plane means an opposite direction. One is pushing towards downwards and another one is pushing upwards. So this concept is based on this concept, the motor is going to work. The motor is the Fleming's left hand rule, principle of Fleming's left hand rule. If you are going to take the middle finger, forefinger and a thumb, if you are going to arrange in 90 degree, this finger shows the direction of the current, this is the magnetic field and the direction of the motion of the conductor. That later on I am going to apply here and I will show you. So the direction of the current, magnetic field, direction of the motion of the conductor. So now we will understand about armature. What is armature? Just a minute, please. See, armature is insulated copper wire coil. Here is also winded like this. It's a coil with two ends. This we are going to call it as commutator. This portion is there, this is the commutator. This is the one end, another end. If you are going to pass a current through this, you can observe both the sides, this side and this side. This is a commutator. Here, if you are going to pass a current through this, around the wire, magnetic field is going to create. Here a soft iron is there, that we are going to call it as a core. So usually what is, according to the textbook, what is armature? Armature is the insulated copper wire coil with rings. We are going to say that. But here we can consider these two are the rings. Here and here, these two parts, this is the rings. So we can conclude that insulated copper wire coil with split rings. In motor, split rings it will come, that we have to concentrate. So this is the armature. And two external magnetic field is here. Here is one, here is another one. See, now we will understand how it is going to work. See now, if you are going to put on the switch, this is rotating, motor is working with simple materials. So one plywood and some wooden pieces, and this is actually a nut and bolt 3 inches, and a speaker behind magnets will be there available. Using that material only we did. This is the low cost no cost material. Using low cost no cost material we did a model of the motor. So next class, that means in next video I am going to show you how it is going to work, and the principles, everything I am going to explain.